and we're going to graph. Okay? So, we're going to do number 5 on this page right here. Okay? I only have graphs for 1 and 2, so I recommend getting a piece of graph paper. It's nice to have the room, too. There's no way that you can do these problems on here. Okay, so you need a separate sheet of paper. All right, so I've got, this is number 5. I'm going to make sure I label this. Okay. All right. So the first thing we need to do is do those 7 characteristics, but I can't do that because my top is not factored. So I'm going to factor my top first. You ready? Okay. What times what gives me 18 but adds together to give me 11? 9 and 2. Positive 9, positive 2, right? Over 2x plus 1. Now, I'm going to label the things I have to do 1 through 7 just so that's easier for me, okay? Number 1, my zeros. Those are also my x-intercepts, where it crosses the x-axis. What are they?
Negative 9 and
X equals negative 9, x equals negative 2. Okay. Number 2 is a little harder, vertical asymptote. It's not super clear. How would I figure out what it is? I would set that whole thing equal to just the bottom, right? Okay. So if I set the bottom equal to 0, I never have enough room, guys, so I'm going to do this right here. 2x plus 1 equals 0. I'm going to get 2x equals negative 1. Divide by 2, and then I'm going to get x equals negative 1/2. Am I going too fast, or are we okay? Now, I couldn't just say 0, right? Because 0 times 2 is 0. 0 plus 1 is 1, right? So I had to find out how to get the bottom 0. And that's my vertical asymptote, because I can never divide by 0. It is. Okay. 3. Horizontal asymptote. Now do we remember the 3 things? If the numerators' exponents are bigger than the denominators, there's no horizontal asymptote. If the numerator and denominator are equal, the leading coefficient, if the numerator and denominator, if the denominator is bigger than the numerator, it's y equals 0. Yes?
Leading coefficient of the numerator and
Them together. So the leading coefficient. So it could be like 2 over 1, or it could be like 1/4, or it could be like 3/5. So like the numerator, the numbers that would be right here in front. Okay? All right. So there's no horizontal asymptote.
what you said the third
Y equals 0. If the bottom's bigger than the top, it's y equals 0. Okay. My oblique asymptote. Is the top one bigger than the bottom? Yes or no?
Yes.
So we have to divide. So I'm going to take x squared plus 11x plus 18, and I'm going to divide 2x plus 1 in it. This is a sucky division problem. Okay? Which is why I'm doing this one with you. All right? What times 2x gives me 1x squared? 1/2. 1/2 x. Right? 1/2 times 2x, 1/2 x times 2x gives me 1x squared. 1/2 times 1 gives me 1/2 x, and we're going to subtract them. Okay? These cancel. I get 10 and a half x, and I'm going to bring down the 18. What times 2x gives me 10 and a half x? 4 and a half gives me 9. 5.25. Or 5 1/4. 5.25 times 2x gives me 10.5 x. 5.25 times 1 gives me 5.25. We subtract, but I don't care what this is, right? This is my oblique asymptote. Y equals, we got this part down? 1.5 x plus 5. I'm going to change it to 5 1/4 because I think fractions are easier to graph than decimals. Okay. End behavior. As x approaches positive and negative infinity, y approaches positive and negative infinity. When would I switch this so that it's as x approaches positive infinity, y approaches negative infinity? What would be true? If there was a negative, if one of these two were negative, the number in front. All right. 6. Is there any removable discontinuity? None. 7. Discontinuity. Negative 1/2. Okay. Now we are going, yes.
Where you get the
Is there anything I could have canceled out because it's on the top and the bottom? Any questions about 1 through 7 before we graph? Okay. This is where I need your full attention. Yes.
I have one question.
Yes.
So, like the bottom where it's 2x plus 1.
Yes.
Why couldn't we like divide by 2? Like I know 1 would go to a fraction, but like why couldn't we like take the 2 out and make it x plus 1 half? It would be like 2 and then in parentheses we x plus 1.
Why would we do that?
No, I'm asking, yeah, why can't we do it?
Why would you want to do that?
I'm just asking, like, I don't know.
I'm just confused. What part are you asking? 1, 2, 3, 4, 5?
Well, like to make sure there's like
Oh,
nothing
to see what the
factor out.
0 is? Oh, to factor?
Like to make sure there's nothing you can't factor.
Well, we can't, like 2 and 1 don't have anything in common, so I can't pull anything out. Neither of them have an x, so there's nothing to pull out of it. Yeah? If it was like 2x squared plus 1x, we could have pulled an x out of it. That kind of thing. Yes?
Let me erase this.
Eventually, Kyle, but I would like you to concentrate on this right now. Okay. Now we're going to graph. I'm going to put a vertical asymptote at negative 1/2. I'm going to move my mouse. Hold on. Okay, focusing. I'm going to put a vertical asymptote at negative 1/2. So I go here and I put a vertical asymptote. I cannot cross this line. I'm going to put x equals negative 1/2 at the top. If you did not do that on your test, you will not get full credit. If you don't put what it equals at the top, you will not get full credit. I want this to be blank so you can see what I'm talking about. There we go. Okay. Now, I don't have any horizontal asymptotes, correct? Do I have any others? My oblique. It is y equals 1/2 x plus 5 1/4. We are going to have to graph a line like y equals mx plus b. So I'm going to start at 5 1/4. So I'm going to count up on my y-axis because this is my y-intercept. 1, 2, 3, 4, 5, and just a little bit above. Am I okay so far? Now I'm going to follow my slope, which is up 1 to the right 2. Up 1, right 2, up 1, right 2, up 1, right 2. And it's really annoying that I keep saying that. Okay, and I could go down 1 to the left 2. You need to do it all the way across your graph paper. Everybody's doing this with me, right?
Yes.
Please do it. We need to label that as y equals 1/2 x plus 5 1/4. Any questions about the asymptote? What? Ah. Okay. Now I am going to, do you need another second? Y equals 1/2 x plus 5 1/4. Questions? Okay, now I'm going to put my zeros in where it crosses the x-axis. You know it crosses at -2, so I go to 0, I go over 1, 2, and I'm going to go over to 9. -9. 2, 3, 4, 5, 6, 7, 8, 9. Okay? My graph always follows my asymptotes. I need to figure out how far up in here I go. So I'm just going to pick a number to plug in between -2 and -9. What number would you like to choose? Okay. I'm going to pick -5. So I'm going to put it in my equation, right? We're going to say -5 plus 9 times -5 plus 2. And we're going to say 2 times -5 plus 1. And then we're going to divide them by each other. And we're going to get 4/3 or 1 1/3. Okay, so I'm going to graph that. -5. So that's 2, 3, 4, 5. +1 1/3. So I know this goes like this. Shape is more important than exactness. It's approaching my asymptotes. Now, there's got to be more than my graph, right? Because I only have the negative sides here. I don't have anything on the positive. So I'm going to have to plug in a negative number. Because my graph could go along my asymptote right here, or it could go along my asymptotes up here. Correct? So let's pick a point that's on the positive side. What point would you like to choose? 4? 4 sounds good. Okay. So I'm going to go 4 plus 9 times 4 plus 2. And I'm going to go 2 times 4 plus 1. And I get 26/3 or 8 2/3, right? Okay, so at 4, 1, 2, 3, 4, I go up 1, 2, 3, 4, 5, 6, 7, 8 2/3. So I know it goes like this. Remember, exactness is an important. Shape and it being between the correct asymptotes is most important. because I know that it has to approach both my asymptotes. So what I'm looking for, I wasn't really looking for the shape. I know what that's going to look like. It's going to approach both asymptotes on either side. I wanted to know if it was up here or down here.
So,
That point made me know that it was up there.
Wait,
so if the point was below that.
Yes, I would know it would go like that. Okay.
Because it can never cross that.
Yes. Okay. I say we try one more of these.
No.
Yep.
No.
Yes.
No.
No, today.
If we were done all
Okay, because you're going to do others for homework, so I want to do another one. All right, let's try 6. We're going to do number 6.
that's a lot.
What's my first step? Always. Take out factor everything, right? So I just have x minus 4 over x times x minus 3, correct? Okay. Number 1, what are my zeros or my x-intercepts? X equals 4. What are my vertical asymptotes?
X equals 0, x equals
Perfect. What are my horizontal asymptotes? Do you remember the rules?
wait. At y equals 0.
The top is smaller than the bottom. It's y equals 0. Is the top one more than the bottom? Yes or no? No. The degrees, the exponents for the top and the bottom are not. So it's none. There is no oblique asymptote. That's nice. We don't have to divide. Right? Okay. Number 5, end behavior. As x approaches positive and negative infinity, y approaches what?
0.
Is there any removable discontinuity?
No.
I didn't cross anything off, right? What's my discontinuity? 0 and 3. So far, so good?
I have a question.
Yes.
Can you have none of both horizontal asymptote and asymptote? Or can you just have one of the other?
I don't know. We'll have to see. So, I have an oblique asymptote only if the top is one more than the bottom. So if the top is bigger than the bottom, it is no horizontal asymptote. So you can only have one of them. I don't feel comfortable about that, but I'm going to say it. Okay. All right. So what is the first thing we do when we graph?
Vertical asymptote.
Graph all the asymptotes. Verticals first. X equals 0. Right down the middle. We must do what to it? What must be true to get full credit?
Label it.
Label it. And x equals 3. 1, 2, 3. X equals 3. And we're going to label our horizontal asymptote. Now, there are certain cases where we can cross horizontal asymptotes. So we have to be careful. So vertical, oblique, we can. Certain horizontal asymptotes we can cross. Okay. So, now, we have to figure out where my graph will go among these. Right? So we're going to have to try each section. We're going to have to try a negative section, a point between 0 and 3, and a point greater than 3. Okay, so we need 3 points for this one. We're good? Okay.
Say that one more time.
We're going to have to do points less than 0, between 0 and 3, and greater than 3. Okay? I'm going to zoom out just a bit. All right. So, I like to kind of set stuff up so I can do this. All right. Let's try 2. That's right between 0 and 3, right? Okay. 2 minus 4 is negative 2. 2. So we get 2 minus 4 is negative 2. 2 squared is 4. 3 times 2 is 6. So we get negative 2. So we get 1. Yeah? When I plug them in? Okay. So at 2, 1, 2, I'm at 1. So I know I'm going to look like this. Because they have to follow the asymptotes. So far, so good?
Yes.
Okay. Let's do a number less than 0. What do you want to do?
Negative 7.
Why? Let's do something that's easy. We can do negative 7.
No, do not do negative 7. Do not listen to me.
Negative 2. Okay. So negative 2 minus 4 is negative 6. Negative 2 squared is 4. Minus 3 times negative 2 is positive 6. Negative 6 divided by 10 is negative 3/5. Yes.
Where are you getting these numbers from?
I'm plugging it into my original equation.
Okay.
So I'm going like negative 2 minus 4 over negative 2 squared minus 3 times negative 2. Yep, all the x's. Sorry. Okay, so I'm going over negative 2, 1, 2, negative 3/5. So it's not even negative 1. So I know it goes like this. Good? Okay. I got to go the other side. What's a number bigger than 3 that I can plug in? 4.
There you go, Kyle.
Nice. Okay. So I'm going 4 minus 4 divided by 4 squared minus 3 times 4. Oh, I should have known that one, right? It's my 0. It's where I hit the axis. So I am going to have to do another point. I don't really know what happens here. Let's do just one bigger.
Kyle, you suck at this.
Let's just do 5. Let's leave Kyle alone. None of the rest of you are helping. Okay.
Yeah.
5 minus 4 divided by 5 squared minus 3 times 5. I get 1/10. So with 5, I'm at 1/10. So I'm going like
Wait, how's the thing?
it did. We can sometimes cross horizontal asymptotes at zeros.
How do you know that it's not going up?
How do I know it's going down?
Yeah, because it says it's 1/10, so that would make me think.
That's a good question. Cause I correct. So we would do 3.5. Okay. So we're gonna do 3.5 minus 4 divided by 3.5 squared minus 3 times 3.5. And we get negative 0.2857 something. So that's how I know.
So, wait. But if I put 5 in, and I got 1/10, I would just stop there. I would think.
Yeah, but you don't know, like you said, you don't know if it goes up and over or down and over. So when you ask yourself that question, Ethan, that's when you know you have to put another point in there just to make sure. So you said, okay, I get 1/10.
Which
So
is
I
above
know,
the azimuth.
but I know it has to cross the 0 because that's my 0 because of number 1.
So it has to touch.
So then you say, okay, is it? Would I go
So-
like
Okay,
this?
so since it has to touch the 0, I want to know if it goes like that or like that.
Yes. And that's why you put in 1 between 4 and 3. To see if I approach the asymptote from the top or from the bottom.
Because the in between center is where
Okay? Alright, let me stop